Right now, as you're watching this, there are more than 10,000 commercial aircraft in the sky. Millions of people moving across continents, oceans, time zones, like it's routine. And for decades, if you were one of them, chances are you were sitting inside one of these. Massive, 4 engines, 2 aisles, a second deck. Aircraft so big when they first appeared, people genuinely questioned whether they should even be able to fly. And yet, they didn't just fly, they dominated the skies. But look at them now, parked, lined up in the desert like abandoned monuments to another era. Because something changed. Not slowly, not quietly, but completely, irreversibly. The biggest planes ever built are disappearing, and the reason why has nothing to do with a single breakthrough. It's a chain reaction, decades in the making. Let's go back. Late 1960s. Air travel is exploding. Passenger numbers are growing between 10 and 20% every year. Airports are overwhelmed, terminals are packed, runways are at capacity. Look at footage from Los Angeles, New York, London during that time. It's pure chaos. And every aircraft in the sky looks almost identical. Single aisle, narrow body, around 120 to 150 passengers. That's the ceiling. So airlines are facing a problem that's getting worse every year. How do you move more people without building entirely new airports? Because cities like New York, London, Tokyo, they're already boxed in. You can't just expand Manhattan. You can't bulldoze entire neighborhoods for more runways.
So the industry is left with 2 options, more flights or bigger planes. And one man decides to push that idea further than anyone else. Juan Trippe, the CEO of Pan Am, walks into Boeing and makes a demand that sounds almost impossible. He doesn't want a slightly bigger aircraft, he wants one that carries more than double. At the time, the Boeing 707 carries about 150 passengers. Trippe wants over 400 in a single plane. Boeing's engineers are skeptical. Some think it won't work at all. The physics alone are intimidating. The weight, the lift, the power required. Nothing like this has ever been attempted. But Boeing agrees, and in doing so, they take one of the biggest risks in corporate history. They invest around $2 billion in 1966. Adjusted for today, that's roughly $18 billion. They build the largest factory in the world just to assemble it. If this fails, Boeing collapses, thousands of jobs disappear, the company doesn't survive. That's the level of risk behind this one aircraft. Then, February 9th, 1969, the first 747 rolls onto the runway, and there's a real question in the air. Will it actually lift off, or will this entire project end in disaster? The engines spool up, the runway disappears beneath it, and then it flies. And in that moment, aviation changes forever, because suddenly, airlines can move hundreds of passengers in a single flight. Think about the math. To move 1,000 people using narrow-body aircraft, you need around 8 to 10 flights. With a 747, you can do it in 2. That means fewer takeoffs, less congestion, more efficiency. But the real breakthrough isn't just operational, it's economic. Because when you pack more people onto one aircraft, the cost per passenger drops dramatically. And over the next decade, ticket prices fall by nearly 40%. The cost to fly 1 person per mile is cut in half. Flying stops being something reserved for the wealthy. It becomes accessible. Middle-class families start booking international trips. Tourism explodes. Business travel expands globally. The world becomes more connected because of one aircraft. And the 747 doesn't just succeed, it becomes dominant for decades. By the 1970s, Boeing is producing them at scale. In peak years, dozens are delivered annually. By the 1990s, multiple 747s are taking off every single hour somewhere in the world. The skies are filled with them, and the platform evolves. Cargo variants where the entire nose swings open so you can load vehicles directly inside. Ultra-long range versions flying routes like New York to Tokyo non-stop. Stretched variants pushing capacity even higher. It becomes Air Force One.
NASA uses it to transport the space shuttle. It's not just an airplane anymore, it's a symbol. For over 30 years, if you crossed an ocean, odds are you were on a 747.
And then Airbus enters the picture, watching closely, learning, and preparing something even bigger. In 2000, Airbus announces the A380. And this isn't just competition, it's escalation. Because the A380 isn't slightly larger than the 747, it's in a completely different category. 2 full passenger decks, front to back. Not a partial upper deck like the 747, 2 complete floors. In a maximum configuration, it can carry over 850 passengers. Think about that. One aircraft moving nearly 1,000 people. Airlines begin designing luxury experiences inside them. Showers, bars, private suites. It's marketed as the future, a flying hotel. Airbus is betting on one idea. Their air travel will revolve around mega hubs.
Cities like Dubai, Singapore, London. You gather massive numbers of passengers into one location, then redistribute them globally. And for a while, it works. Airlines place orders. Emirates in particular goes all in, eventually ordering over 100 A380s. The strategy seems solid. The aircraft is impressive. The future looks set. And then, everything shifts. Fuel prices. In 2008, oil spikes to around $140 per barrel. And suddenly, the economics of aviation change overnight. Because fuel isn't just a line item. It's the biggest cost airlines face, and 4-engine aircraft burn significantly more fuel than twin-engine alternatives. For example, a 747 burns roughly 12 litres of fuel per passenger per 100 kilometers. A newer aircraft like the 787 burns closer to 8 litres. That's about a 30% reduction. And over the life of an aircraft, that difference adds up to tens of millions of dollars per plane.
Multiply that across a fleet, and you're looking at billions. And airlines notice. At the same time, another shift happens, quietly. Regulations. For decades, twin-engine aircraft weren't allowed to fly long distances over oceans. They had to stay within a certain distance of diversion airports, which made 4 engines essential for long-haul travel. But then ETOPS changes everything. If an aircraft proves its engines are reliable enough, it can fly those routes with just 2. And modern engines deliver. Reliability rates exceed 99.9%, which means the rule that once made jumbo jets necessary disappears. And then comes the final shift, passenger behavior. Because airlines start realizing something important. People don't like connections. They don't like layovers. They don't like spending hours in massive hub airports. So instead of flying 500 passengers on one route once per day, airlines start flying 200 to 300 passengers multiple times per day to multiple destinations. Direct flights, point to point. Instead of London only, you now have London, Manchester, Edinburgh. More convenience, more flexibility, and passengers overwhelmingly prefer it. So now you have everything happening at once. Fuel costs rising, technology improving, regulations changing, passenger preferences shifting, and together, they completely reshape the industry. Orders for jumbo jets collapse. At the same time, demand for smaller, more efficient twin-engine aircraft explodes. The Boeing 787 alone racks up over 1,400 orders. The 777 becomes a long-haul workhorse. Airlines shift their fleets rapidly, and the giants start to fade. Airbus delivers its final A380 in 2021, after just 14 years of production, much shorter than expected. Boeing continues with the 747, but even that can't last. They launched the 747-8 in 2011 with improved efficiency and modern upgrades, but airlines aren't interested. Only a small number of passenger versions are ever sold. And then, January 31st, 2023, the final 747 rolls out of the factory after 54 years. An aircraft that defined an era quietly ends production. Today, many of them sit in places like Mojave, Victorville, and Arizona desert storage facilities. Engines wrapped, windows sealed, waiting. Some will be converted into cargo aircraft. A few might fly again, but most will never leave the ground. And that's what makes this story so strange, because these aircraft didn't fail.
They solved the exact problem they were built for. They made air travel accessible. They connected continents. They changed the world. But the world kept moving, and aviation moved with it. Because in the end, bigger wasn't better. Better was smarter, more efficient, more flexible, and easier to scale. And now, when you look up at the sky, you'll still see thousands of aircraft, still carrying millions of passengers, still connecting the world. But the giants that once ruled it are slowly disappearing.